Hi everyone, let's talk about other types of functions. So Mr. Kwan is looking at changing his cell phone plan because mine is currently getting so expensive. I look at switching to Google Fi's plan. For any given month, they charge a $20 base fee and then $10 for every gigabyte of data that you use. Data is free after you've used 6 gigabytes of data. This is Google Fi's actual pricing, so you're helping me, Mr. Kwan, with my cell phone bill. Let's assume that Mr. Kwan signs up for this Google Fi plan, and let's ignore taxes and fees for the purposes of these questions. If Mr. Kwan used 4.2 gigabytes of data in a given month, how much will his bill be given that he switches to Google Fi? So we know that there is a $20 base fee, and we also know that it is $10 per gigabyte. I'm going to abbreviate GB. As long as that's before 6 gigabytes. And so we do know that it's 4.2 gigabytes, which is less than 6. So we're going to have 20 plus 10 times 4.2. And so that's going to be 20 plus 42, which is going to end up being $62. All right, so part B says, if Mr. Kwan used 7.8 gigabytes of data in a given month, how much will his bill be? So again, we know that we have that $20 base fee plus 10 times the amount of gigabytes of data that we use. However, note that it says data is free after you've used 6 gigabytes. So this question is specifically asking, what if we use 7.8 gigabytes of data? Since that number is larger than 6, we basically only want to multiply by 6 because any data used after 6 gigabytes is free. So we'll get 20 plus 10 times 6, which is 60. So our total will be $80. I forgot to box the answer in the previous example, so I'll do that now. And then part C says, sketch a graph where the independent or input variable is the number of gigabytes Mr. Kwan uses, and the dependent or the output variable is the total cost of Mr. Kwan's bill. Now, it may seem at first glance that this is a linear function, but it's not actually a linear function, but it seems like it is, and I'll tell you why. So let me plot my axes really quick. And we know that the horizontal axis is gigabytes of data used. And our vertical axis is total cost of bill in dollars. So I'm going to increment these by 10 units or $10 on the vertical axis. And I'm going to increment these by 1 gigabyte. Okay, so it kind of starts off like a linear function because if I use 0 gigabytes, then I just have that $20 base fee there. And if I use 1 gigabyte, that's an additional $10, so that's going to be there. If I use, let's say, 4 gigabytes, then it'll be 20 plus 40, which is 60. So that's about there. Now, we know when we use 6 gigabytes, we calculated that would be $80. However, if we used 7.8 gigabytes, which is about here, that was also $80. So what ends up happening is this function is actually kind of two different functions put together. So let's see that with our ruler. Okay, so our line or graph looks something like that up until we use 6 gigabytes. But then after 6 gigabytes, it just continues to be the same cost because they're not charging us anything additional for that data that we're using. So our graph is going to look something like that. Okay, so notice this is not a linear function because if it was a linear function, it would just be one single straight line. But this is a combination of like two different linear functions. And whenever you combine multiple different functions like this, it's what we call a piecewise function. And the next part D, says, how do you know that this graph represents a function? Well, if I take any vertical line, if I run the vertical line test, it only intersects the graph at all of these places at exactly one spot. So for this one, we can say it passes the vertical line test. And so part E says create a function f of x that models this scenario. So we want to say f of x equals, now if it were just a linear function, remember a linear function looks like this, f of x equals mx plus b. And it kind of seems like it would be the linear function 10x plus 20, since the base fee is $20 and the slope, or the cost per gigabyte, is $10, but that doesn't represent the entire graph. That's only a portion of it. And so this is, like I said earlier, what we're doing is we're creating what's called a piecewise function. And when we create a piecewise function, we use this little curly bracket thing here. And that basically just says we have like different functions that we're combining together to make one overall function. And generally, we put like a comma here to denote the domain on which we are taking on this function. So if we go back to the graph, what you'll notice is that it takes on that function when our input values are between 0 and 6. And so if I come back here, it's separated by a comma. Sometimes you'll see the word if instead of a comma, but that means the same thing. And so here, generally in piecewise functions, we use inequality notation. So I'm going to put 0 is less than or equal to x, which is less than or equal to 6. Okay, and notice that the next portion of our graph, this portion right here, that is a horizontal line. And remember from a previous outline that whenever we have a horizontal line, then we just have like y equals like b or some number there. And in this case, it's going to be 80. So the next part of our function is 80, like that. And our function or output is 80 whenever the amount of gigabytes that we use is greater than 6. So this is our piecewise function that we want.